liftoff of the Falcon 9 and
The mission, called DART, began last year, with the spacecraft starting its epic journey to its destination. The target, a twin asteroid system.
We are monitoring a live situation right now. It's actually a major collision in space, so let me tell you about it. This is a live image on your screen. NASA is about to intentionally crash a spacecraft into an asteroid, and they're going to do it right here on live television, and literally we're in the last minute.
But this is it, the moment. DART hitting the Dimorphos asteroid. Right now, wow, look at the detail that you can see.
It is amazing. It looks like a...
So those are rocks on the surface of Dimorphos of some kind. Big cheers going up here.
Has NASA saved humanity from an apocalypse? We should often get jealous of them for playing the characters of movie heroes in real life. On September 26, 2022, NASA completed the DART mission successfully and released its first images. This incident was also covered by many space telescopes and, for the first time, by both Hubble and James Webb Space Telescopes in the visible and infrared regions of light. What was this mission all about? What have these super telescopes of humans recorded from this event? What can we gain from this mission in the future? Let's roll into the video to answer these questions. After 10 months of flying in space, NASA's Double Asteroid Redirection Test, DART, the world's first planetary defense technology demonstration, successfully impacted its asteroid target on Monday, September 26. DART was the first attempt to move an asteroid object in space while analyzing a technique termed Kinetic Impact. One more significant thing to mention here is that the target of this mission, Dimorphos, neither had any threat to Earth, nor did the Didymos, the bigger asteroid whom Dimorphos orbits. But there are asteroids in outer space that has the potential to destroy the planet. So the proactive approach has been used by NASA to deflect an object way away from the Earth if an apocalyptic event of such nature is likely to happen. This mission has two primary objectives: to demonstrate a hypervelocity spacecraft impact on a small near-Earth asteroid, NEA. 2. To measure and understand the deflection caused by the impact. At its core, DART represents an unprecedented success for planetary defense, but it is also a mission of unity with a real benefit for all humanity, said NASA Administrator Bill Nelson. As NASA studies the cosmos and our home planet, we're also working to protect that home. And this international collaboration turns science fiction into science fact, demonstrating one way to protect Earth. DART targeted the asteroid moonlet Dimorphos, a small body just 530 feet, 160 meters, in diameter. It orbits a larger 2,560 foot, 780 meter asteroid called Didymos. The investigation team will now observe Dimorphos using ground-based telescopes to confirm how much DART's impact has altered the asteroid's orbit around Didymos. Researchers expect that this impact will shorten Dimorphos' orbit by about 1%, or roughly 10 minutes. Planetary defense is a globally unifying effort that affects everyone living on Earth, said Thomas Zurbuchen, Associate Administrator for the Science Mission Directorate at NASA headquarters in Washington. Now we know we can aim a spacecraft with the precision needed to impact even a small body in space. Just a small change in its speed is all we need to make a significant difference in the path an asteroid travels. We believe that we do not have to explain how significant this little speed can prove when we talk about distance in light years. The spacecraft's sole instrument Draco, Didymos reconnaissance and asteroid camera for optical navigation, together with sophisticated guidance, navigation, and a control system that works in collaboration with SmartNav, small body maneuvering autonomous real-time navigation. Algorithms enable DART to identify and distinguish between the two asteroids, targeting the smaller body. Well, NASA and its queer names. These systems guided the 1,260-pound, 570-kilogram box-shaped spacecraft through the final 56,000 miles, 90,000 kilometers, of space into Dimorphos, intentionally crashing into it at roughly 14,000 miles, 22,530 kilometers per hour to slightly slow the asteroid's orbital speed. Draco's final images, obtained by the spacecraft seconds before impact, revealed the surface of Dimorphos in close-up detail. "15 days before impact, DART's CubeSat companion Licia Cube, provided by the Italian Space Agency, deployed from the spacecraft to capture images of DART's impact and of the asteroid's resulting cloud of ejected matter. In tandem with the images returned by Draco, Licia Cube's images are intended to provide a view of the collision's effects to help researchers better characterize the effectiveness of kinetic impact in deflecting an asteroid. Because Licia Cube doesn't carry a large antenna, images will be downlinked to Earth one by one in the coming weeks. Webb took one observation of the impact location before the collision took place, then several observations over the next few hours. Images from Webb's near-infrared camera, NIRCam, show a tight, compact core, with plumes of material appearing as wisps streaming away from the center of where the impact took place. Observing the impact with Webb presented the flight operations, planning, and science teams with unique challenges. Because of the asteroid's speed of travel across the sky, the teams worked in the weeks leading up to the impact to enable and test a method of tracking asteroids moving over 3 times faster than the original speed limits set for Webb. Don't stop here. This is the part where we realize that real science is perhaps more advanced than science fiction movies. Scientists also plan to observe the asteroid in the coming months using Webb's mid-infrared instrument, MIRI, and Webb's near-infrared spectrograph, NIR-SPEC. Spectroscopic data will provide researchers with insight into the asteroid's chemical composition. Webb observed the impact over 5 hours total and captured 10 images. Hubble also managed to capture observations of the moonlet ahead of the impact, then again 15 minutes after DART met the surface of Dimorphos. Images from Hubble's Wide-Field Camera 3 show the impact in visible light. Ejecta from the impact appears as rays stretching out from the asteroid's body. Some of the rays appear slightly curved, but astronomers need to look closer to determine what this could mean. In the Hubble images, astronomers estimate that the brightness of Didymos increased by 3 times after impact and are also particularly intrigued by how that brightness then held steady, even 8 hours after the crash. It is too early to make any conclusion on the physics of these events. Hubble will monitor Dimorphos 10 more times over the next 3 weeks. These regular, relatively long-term observations as the ejecta cloud expand and fade over time will paint a complete picture of the cloud's expansion from the ejection to its disappearance. Hubble captured 45 images in the time immediately before and following DART's impact with Dimorphos. The Hubble data was collected as part of Cycle 29 General Observers Program 16,674. With the asteroid pair within 7 million miles, 11 million kilometers of Earth, a global team uses dozens of telescopes stationed worldwide and in space to observe the asteroid system. Over the coming weeks, they will characterize the ejecta produced and precisely measure Dimorphos' orbital change to determine how effectively DART deflected the asteroid. The results will help validate and improve scientific computer models critical to predicting the effectiveness of this technique as a reliable method for asteroid deflection. DART's success provides a significant addition to the essential toolbox we must have to protect Earth from a devastating impact by an asteroid, said Lindley Johnson, NASA's planetary defense officer. This demonstrates we are no longer powerless to prevent this type of natural disaster. With the added aid of DART's successor Near-Earth Object, NEO, Surveyor, these 2 missions will help to accelerate the finding of the remaining hazardous asteroid population and what we need to save the day. This first-of-its-kind mission required incredible preparation and precision, and the team exceeded expectations on all counts. Beyond the inspiring success of the technology demonstration, capabilities based on DART could one day be used to change the course of an asteroid to protect our planet and preserve life on Earth as we know it. The future looks bright, and so will our channel with a precious subscription from your account. Please also like the video and give us your valuable feedback in the comments section.